Your future is already sitting somewhere, waiting for you to arrive. That is what the mathematics quietly says. Not as a metaphor, not as a philosophical mood, as a direct consequence of the same equations that guide GPS satellites and predict the orbits of planets. If those equations are right, and every experiment for more than a century has confirmed that they are, then something very strange follows from a small, familiar act. Turning around, taking a step, walking slowly toward a friend on the sidewalk. Stay with me and you will see how a slow walk quietly rearranges the map of what is real, not on Earth, not in the room where you are sitting, but across a distance so large that no signal in this universe has ever crossed it. Here is the claim we are going to examine. Two strangers pass each other on a street. One keeps walking north. The other keeps walking south. They are the same age, the same height, the same species, breathing the same air. And yet, according to the standard mathematics of relativity, the two of them do not agree about the state of a galaxy 2.5 million light-years away. They disagree by roughly 6 days. In one person's version of the present, an event over there has not yet occurred. In the other person's version of the present, it already has. A war has begun. A star has died. A civilization has made a decision. This is not science fiction. It is the mathematical setup that Roger Penrose used to illustrate what philosophers call the Andromeda paradox, a straight-line implication of the Rietdijk-Putnam argument, itself a straight-line implication of Einstein's special relativity. By the time this exploration ends, you will understand where that 6-day number comes from, why some of the most careful minds in physics say it means the future already exists, why others say the argument is a trick of a diagram, and where the honest evidence actually points once the pretty analogies are cleared away. If you find value in explorations like this, the subscribe button quietly helps these deep dives reach more curious minds. So, here is where it begins. Two strangers on a sidewalk, and a galaxy so far away that its light left before there were cities. The galaxy is Andromeda. In astronomical catalogues, it is Messier 31, or M31. It is the nearest large spiral galaxy to our own, a wheel of stars roughly 152,000 light-years across, containing something on the order of 1 trillion suns. Measured from Earth, Andromeda sits about 2.5 million light-years away. That figure was directly confirmed by eclipsing binary distance measurements in 2005, which pinned the distance at 772 kiloparsecs, plus or minus about 44 kiloparsecs. In older units, that is about 23 sextillion meters. In the units human bodies actually understand, it is roughly 14.5 quintillion miles. Numbers of that size do very little for most of us. What matters is that Andromeda is so remote that light itself, the fastest signal there is, takes 2.5 million years to make the crossing. When the light that will strike your eye tonight left Andromeda, there were no cities on Earth, no pyramids, no writing, no wheel. Our species did not yet exist in the form it does now. The photons that will land on the back of your retina were emitted from a galaxy whose stars have since aged, drifted, and in some cases died. But you will never see any of that. You will see the state Andromeda was in 2.5 million years ago. That is what an astronomer means by looking at Andromeda. Now hold that image and change one small thing about it. Change the observer's motion. The theory of special relativity, formulated by Albert Einstein in 1905 and given its geometric shape by Hermann Minkowski 3 years later, does something quietly enormous to the everyday idea of a shared present. It removes it. In Newton's physics, there is one universal clock. Every event, everywhere, is either happening now, or in the past, or in the future, and everyone agrees. In Einstein's physics, that universal clock is gone. Time is not a stage on which everything happens. Time is a coordinate, one of 4 coordinates that describes each observer's slice through a larger structure called space-time. The rule that governs how different observers relate their coordinates is called the Lorentz transformation. In one direction of motion takes the form t prime equals gamma times t minus vx over c squared, where gamma is 1 over the square root of 1 minus v squared over c squared. The variables are simple enough. Little t and little x are the time and position of an event as one observer measures them. V is the relative velocity between 2 observers. C is the speed of light in a vacuum, a fixed number, roughly 2.998 times 10 to the 8th meters per second, or a little over 670 million miles per hour. From this one rule, everything that made 20th century physics strange flows out. Moving clocks run slow. Moving rods contract along the direction of motion. And 2 events that one observer calls simultaneous, another observer, moving at a different velocity, does not. This last point is where our story lives. The relativity of simultaneity. We can strip the Lorentz rule down further for slow motions. When v is a small fraction of c, the difference between what 2 observers call now over there is very close to the product of their relative velocity and the distance to the far event, divided by c squared. Written cleanly, delta t is approximately vx over c squared. Speakable, that is, delta t equals v times x divided by c squared. That single expression, a velocity times a distance divided by the square of the speed of light, is the mathematical heart of the Andromeda paradox. Take a walking pace, 1 meter per second, about 2.25 miles per hour, a comfortable stroll. Take the distance to Andromeda, about 2.5 million light years, which converts to roughly 2.37 times 10 to the 22nd meters. Divide by c squared, about 8.99 times 10 to the 16th meters squared per second squared. The answer is roughly 263,000 seconds. Divide that by 86,400 seconds in a day, and you get about 3 days. 3 days of offset per observer between a stationary person and a slow walker for events at Andromeda's distance. That figure has been worked out independently at least twice, most famously by the University of Texas at Austin physics group, whose derivation gave a number identical to Penrose's own back-of-the-envelope estimate. Each observer contributes about 3 days of offset. Two walkers moving in opposite directions therefore disagree about the Andromeda now by about 6 days. Take a moment with that. A pedestrian walking in one direction has a mathematical present that includes an Andromeda event. Another pedestrian walking the other way has a mathematical present in which that same event is still 6 days in the future. This is not a claim about what any observer can see. Light takes millions of years to arrive. Nobody on the sidewalk observes Andromeda in real time. It is also not a claim about what any observer can signal or influence. No message, no cause, no push travels faster than light. And Andromeda lies so far outside our causal reach that any effect we could send is millions of years away from mattering. The paradox is not about what is visible, or about what is happening in any operational sense. The paradox is about what each observer's mathematical frame assigns to the label present. In the standard interpretation of special relativity, that assignment is not arbitrary. It follows from the geometry Minkowski gave us in 1908. Every observer at every moment has a plane of simultaneity, a three-dimensional slice through the four-dimensional block of space-time, containing all the events that observer calls happening now. When an observer changes velocity, that slice tilts. A different plane cuts through the block. And when the plane tilts, it sweeps through events that were not on the original slice at all. Here is the picture Penrose drew, in almost exactly these words, in his 1989 book, The Emperor's New Mind. Two people pass each other on the street. According to one of the two people, an Andromedan space fleet has already set off on its journey. According to the other, the decision as to whether or not that journey will take place has not yet been made. Was there any uncertainty about that future? Or was the future of both people already fixed? The question is not rhetorical. It follows from the mathematics. We will return to it. Because before that question can be answered honestly, several other questions must be laid out on the table. What is a plane of simultaneity, really? Where does the 6-day figure come from in more detail? What did Einstein himself say about the now? Who first pushed the paradox into a formal argument about the reality of past, present, and future? And who fought back? What does quantum mechanics do to a fixed future, if anything? What does the interior of a rotating black hole have to do with any of this? And most importantly, how much of the eternalist conclusion is actually forced by the physics, and how much of it is smuggled in by an assumption that the physics does not require? Set those questions aside for now. We will build up to each of them. First, the plane landscape. The mathematical statement that time and space cannot be cleanly separated is a mature and heavily tested part of physics. When Einstein published his 1905 paper on the electrodynamics of moving bodies, He was addressing a specific tension. Two 19th century pillars, Newtonian mechanics and Maxwell's equations for the electromagnetic field, did not fit together. Newton's rules said the laws of motion should look the same in any frame moving at a constant velocity. But the speed of light in Maxwell's equations was a specific number, apparently locked to no particular frame. Einstein's move was to keep both principles and pay whatever price the mathematics demanded. The price was the absolute Newtonian present. 3 years later, Minkowski, who had been Einstein's mathematics teacher, made the picture geometric. Space and time, taken separately, would sink into shadows, he said, and only a kind of union of the two would preserve an independent reality. That union, the four-dimensional Minkowski spacetime, is the arena in which the rest of this story takes place. Points in it are called events. Continuous curves in it are called world lines. And the shape that separates future from past at any point is the light cone. A double cone of directions along which nothing faster than light can pass. Inside the cone, the causal past and the causal future. Outside it, the space-like separated regions where the labels before and after are not absolute but depend on the observer's frame. Andromeda is in the space-like separated region of the two pedestrians on our sidewalk. It is far enough away that any signal sent now at the speed of light will not arrive there for 2.5 million years. And that is precisely why the labels the two pedestrians assign to Andromedan events can differ by 6 days without any contradiction. Nothing in either observer's causal experience overlaps with those Andromedan events. The disagreement is legal. Legal or not, it feels enormous. And it was enormous enough that in 1966, the Dutch physicist C.W. Rietdijk turned it into a formal argument, published in the journal Philosophy of Science, under a title that made no attempt at modesty. A rigorous proof of determinism derived from the special theory of relativity. A year later, the American philosopher Hilary Putnam, working entirely independently, published a paper called Time and Physical Geometry in the Journal of Philosophy that reached almost exactly the same conclusion. Rietdijk framed the result as a proof against libertarian free will. Putnam framed it as a metaphysical claim about the equal reality of all events in space-time. The argument, in cleaned-up form, runs like this. Consider two observers, call them A and B, who exist at the same spatial point at some moment. In A's frame, a distant event E is happening now, so E must be as real as A. Now consider observer C, who is moving relative to A, but happens to pass through the same point at the same moment. In C's frame, a different distant event, F, is happening now, so F must be as real as C. But A and C are at the same point in space-time, and it makes no sense to say one is real and the other is not. Therefore, both E and F are real. Iterate this reasoning across enough frames and enough distances, and the conclusion drops out. Every event in space-time is as real as every other. The past, the present, and the future are all equally there. This position has a name. It is called eternalism, or the block universe view, or four-dimensionalism, or B theory of time. Presentism, the intuitive view that only the present moment exists, is, on this argument, false. Rietdijk did not stop at "the future exists." He went one step further and drew the determinist conclusion out loud. If the future is fixed and real, then whatever a person will do is already there in the block, waiting. The subjective sense of open possibilities is, at best, a shadow. The appearance of choice from the inside of a static structure. This is the strong reading, and Rietdijk owned it in the title of his paper. Notice what has just happened. A local paradox, a 6-day disagreement about the label "now" for events at a distant galaxy, has quietly been amplified into an ontological thesis about the entire universe and every conscious being in it. This is a leap. Whether the leap is warranted is one of the deepest questions in the philosophy of physics, and we will spend a great deal of time examining it. Before we do, we should meet the geometry more slowly. Draw two axes on a piece of paper. Call the horizontal axis x, a direction in space. Call the vertical axis t, time. This is the simplest Minkowski diagram, and it is a two-dimensional cartoon of a much larger picture. An event is a single point on this diagram. A world line, the entire history of a stationary particle, is a straight vertical line. A world line of a particle moving in the x direction at constant speed is a tilted straight line. Light at speed c traces the two 45-degree lines that make an X shape on this diagram, provided we choose units in which c equals 1. A stationary observer's plane of simultaneity, really a line in this two-dimensional version, is horizontal. It says everything on this line, however far away in x, counts as happening at the same time as me. Now let another observer move in the positive x direction with a constant velocity. Do the algebra of the Lorentz transformation. What comes out is that this second observer's line of simultaneity is not horizontal. It is tilted upward. Tilted in exactly the way that keeps the speed of light equal to c for both observers, no matter how fast they are moving relative to each other. That tilt, as small as it is at walking speeds, is the paradox in geometric form. At the position of Andromeda, enormously far along the x-axis, more than 23 sextillion meters out, a tiny tilt at the origin becomes a huge vertical displacement out there. That vertical displacement is a time offset, 6 days for two walkers on a sidewalk. The picture is elegant. It is also, for many careful thinkers, precisely the moment where the trouble starts. The picture treats the plane of simultaneity as a real thing, a slice cut out of a real, pre-existing block. Whether that block exists as anything more than a bookkeeping device is a question the diagram cannot answer. The diagram is a diagram. It draws the mathematics beautifully. What the mathematics is a diagram of is, as we will see, still under argument. For now, take the diagram at face value. That is what the opening of any honest treatment of the Andromeda paradox has to do. Set the machinery on the table. Turn the wrench. Show that the 6-day number is not a rhetorical trick, but a direct output of Lorentz's rule. And note, quietly, that the leap from "the labels differ" to "the future is real" requires an assumption we have not yet paid for. Keep this open loop in mind. We will need to name that assumption, and we will need to test whether the physics forces us to accept it. Not yet. First, the rest of the landscape. The Andromeda argument is one specific version of a much older question in philosophy. A question about the nature of time itself. That question long predates Einstein. The English philosopher John MacTaggart, Ellis MacTaggart, in a paper published in 1908, the same year Minkowski gave his Space and Time lecture, laid out a distinction that is still used today. He called it the difference between the A series and the B series. The A series is the way time feels from inside. Events are past, present, or future. There is a running now that constantly moves. What was future becomes present, then slides into the past. Time as a river, or as a spotlight sweeping along a corridor. The B series is the way time appears in physics equations. Events stand in fixed relations to each other, earlier than, later than, simultaneous with, but no event is intrinsically present. The whole structure just is. Time as a laid-out map, or as a film strip already exposed. MacTaggart argued, in a move that stunned philosophers of his generation, that the A series is incoherent. His argument is not what matters here. What matters is that the vocabulary, A series and B series, tensed time and tenseless time, became the standard way of asking whether reality has a fundamental now running through it, or whether the now is a psychological artifact projected onto a static structure. Eternalism is the metaphysical position that says the B series is fundamental and the A series is either derivative or illusory. Presentism is the position that says the A series is fundamental and only the present moment truly exists. The growing block view, associated with C.D. Broad, says the past and present are real, but the future is not. The block grows as events become present. Rietdijk and Putnam thought they had a physics argument that decided the metaphysical question. They thought special relativity forced eternalism. Their argument does not depend on any exotic technology, on any subtle quantum experiment, on anything beyond the geometry of Minkowski spacetime and the Lorentz transformation. It depends on the very same equations that describe the muon lifetimes in cosmic ray showers, the atomic clocks on GPS satellites, and the timing signals from every large particle accelerator on Earth. Those equations work. They work to spectacular precision. The Andromeda number, 3 days per observer at walking pace, falls out of them with no adjustment. That is the neutral part. The equations give a number. The number is very large. The number describes disagreements about the label present for events at galactic distances. The step from the labels disagree to the labels correspond to something in the world is the step we have not yet interrogated. We have only planted the seed that we will interrogate it later. In the meantime, other physicists, later and independently, added weight and shape to this picture. The English philosopher Nicholas Maxwell revived the Rietdijk-Putnam argument in 1985, giving it new attention in the philosophy of physics literature. Roger Penrose, in 1989, popularized the Andromeda version in a book that reached far beyond specialists, The Emperor's New Mind. The Bulgarian-Canadian physicist and philosopher Vesselin Petkov defended the block universe view aggressively, arguing that length contraction and time dilation themselves become unintelligible unless the world tubes of physical objects are treated as real four-dimensional entities. Others, Howard Stein, Stephen Savitt, Tim Maudlin, N. David Mermin, dissented. We will spend a substantial portion of this exploration on those dissents. They are not fringe views. They are careful, technical rebuttals from professionals who understand the same mathematics as the eternalists and reach very different conclusions from it. There is one more piece of neutral setup we should get on the table before going deeper. The famous letter. In March of 1955, Albert Einstein wrote to the family of his lifelong friend Michael Besso, who had just died. He wrote, in the well-attested German original, "For people like us, who believe in physics, the distinction between past, present and future has only the meaning of a stubbornly persistent illusion." That line, in that form, is verified. It appears in Freeman Dyson's memoir, Disturbing the Universe, in Alice Calaprese's authoritative Ultimate Quotable Einstein, and in the underlying Einstein Archives correspondence. It has been quoted, re-quoted, and cited in nearly every popular treatment of the block universe. It sounds, on the surface, like a strong personal endorsement of eternalism by the founder of relativity. Keep the quote in mind. Keep it in mind alongside another, less quoted admission from Einstein, one recorded by the philosopher Rudolf Carnap in his intellectual autobiography. Einstein, Carnap wrote, said that the problem of the now worried him seriously. He explained that the experience of the now means something special for man, something essentially different from the past and the future, but that this important difference does not and cannot occur within physics. That this experience cannot be grasped by science seemed to him a matter of painful but inevitable resignation. Two admissions from the same man. One sentence that looks like an eternalist manifesto, another that looks like an admission that the entire framework of physics is missing something about the now that human experience insists is real. We will return to both. Neither is as simple as it appears in a headline. For now, we have the setup. A slow walk on a sidewalk, a galaxy 2.5 million light-years away, a tilt in a plane of simultaneity, a 6-day offset, a formal argument from a Dutch physicist and an American philosopher, a dramatic version by Penrose, a block universe conclusion, and a small pile of admissions and rebuttals that we have not yet processed. Everything we have said so far is the neutral floor. It is what a fair reporter, reading the physics honestly, would put on the table. What comes next is deeper, and in what comes after that, we will start naming the assumptions that the block universe argument has been quietly asking us to grant. The evidence is on the table. Now, the deeper current. To understand where the Andromeda argument actually leads, and where it can and cannot go, we have to slow down and look carefully at what Minkowski's geometry does. It is more than a diagram, it is a claim about what a physical theory is describing. In Newton's physics, space and time are separate stages. There is a three-dimensional space at every instant, and time is a scalar parameter that ticks the same for everyone. In Einstein's physics, the separation is broken. There is one four-dimensional structure, space-time, and observers slice it in different ways. The slicing is not free, it is constrained. Every observer's slice is a space-like hypersurface, meaning that no two events on it can be connected by a light speed or slower signal. This constraint is what makes the slice a candidate for a simultaneity plane at all. It is also, as we will see, one of the places where the metaphysical argument can be resisted. The Lorentz transformation quantifies the constraint. Consider two events on the plane of simultaneity of a stationary observer. They both have time t equals 0 in that frame. Their spatial positions are x1 and x2. Now consider a second observer moving at velocity v in the x direction. In that observer's frame, the two events have times t1' and t2'. Using the reduced form we have already met, the difference is delta t' equals gamma times v times delta x divided by c squared, where delta x is x2 minus x1 and gamma is the Lorentz factor. For small v, gamma is essentially 1. The offset scales linearly with delta x, with the distance between the two events. At walking speeds and everyday distances, the length of a room, the width of a city, the diameter of the Earth, the offset is unmeasurable. At Andromeda's distance, it becomes days. Take the distance to Andromeda in meters, about 2.37 times 10 to the 22nd. Multiply by 1 meter per second, divide by c squared. 263,000 seconds. 3 days. Everyone who has worked through this calculation gets essentially the same number. The University of Texas Group's derivation, published as an educational note under the title Andromeda's New Clothes, writes it as delta t equals delta x over c, which, for these units, yields the same 3-day figure. Penrose himself, in Emperor's New Mind, describes the effect as several days. a phrasing consistent with the more precise calculation. 6 days at Andromeda. Now scale up. For a highway car at 30 meters per second, a modern freeway speed of about 67 miles per hour, the Andromeda offset climbs to about 91 days per observer, roughly 3 months. For a jet airliner at 250 meters per second, the offset reaches around 2.1 years per observer. And these numbers scale linearly. Double the distance, double the offset. A galaxy 100 million light-years out, at walking speed, has a simultaneity offset of about 120 years. A galaxy at the observable universe edge, at walking speed, has an offset that spans much of a human lifetime. Notice what happens when you keep pushing. Nowhere in this calculation does anything travel faster than light. Nowhere is any message sent. No matter is displaced. No energy is transferred. The offset is a difference in how two observers foliate the same block of space-time, how they cut the same loaf of bread at different angles. Nothing gets from one observer's slice to the other's. That last point is easy to miss and easy to misuse. The Andromeda paradox does not enable any form of superluminal communication. It does not give a walker the ability to change what an Andromedan does. It is not a mechanism. It is a labeling difference across space-like separated events. Because Andromeda is space-like separated from a walker on Earth, no causal connection exists between them, and no experiment on Earth or on Andromeda can detect the disagreement. The disagreement is between two coordinate systems that both accurately describe the same underlying space-time. This is why some careful physicists say the paradox is really a paradox about words or about pictures, and not a paradox about the world. We will get to that argument later. For now, we can already see the shape of it forming. But there is a stronger version of the eternalist claim that we should meet honestly. That is Vesselin Petkov's argument. Petkov, who has written extensively in defense of the block universe from the physics side rather than the philosophy side, points out that special relativity's most everyday predictions, length contraction and time dilation, become inexplicable if we insist that only a three-dimensional present is real. Consider two observers watching a meter stick move past them at high speed. Each observer measures the stick to be shorter than a meter. Not shorter in a metaphorical way, shorter in a way that could be photographed if the photographs were properly time-synchronized. Petkov argues that if the meter stick is really just a three-dimensional object that exists only in the present, this contraction is nonsense. The different observers are measuring different three-dimensional presents. The only way to make length contraction consistent with the empirical data, in Petkov's view, is to treat the meter stick's history as a four-dimensional world tube, and to treat the two observers as cutting that world tube at different angles. The three-dimensional meter stick each observer measures is then their own particular slice through a four-dimensional reality that all observers share. If Petkov is right, the block universe is not a philosophical add-on to special relativity. It is what special relativity is a theory of. The moving stick, the ticking clock, the walker on the sidewalk are all four-dimensional world tubes embedded in a static Minkowski spacetime. And the disagreements between observers are the different ways their frames intersect the same underlying structure. Petkov's argument has strong defenders. It also has strong critics. Both camps are in the peer-reviewed literature. It is not a settled question. Take a breath. This is the part that stays with me. Not the diagrams, not the 6 days. The way a whole metaphysical position can hinge on how one interprets an experiment that has been done thousands of times. The way a coordinate transformation becomes, in some hands, a claim about existence. The way the pieces fit together so neatly that it is easy to forget how many quiet assumptions had to be granted along the way. We will return to those assumptions. For now, back to the deeper landscape. Any serious discussion of the Andromeda paradox has to grapple with what happens when quantum mechanics is added to the picture. The standard block universe presentation is a purely classical story. It uses the classical Lorentz transformation, the classical Minkowski geometry, and a classical notion of an event as a definite point in space-time. But actual matter, the particles that make up the walkers, the sidewalk, the light bulbs, the stars in Andromeda, is described by quantum mechanics. And quantum mechanics has a very different relationship with the future than classical relativity does. The Schrödinger equation, the fundamental equation of non-relativistic quantum mechanics, is deterministic. Given a wave function psi at some time, it fixes psi at every future time by the rule I h bar times the partial of psi with respect to t equals h hat psi. I times h bar times the partial of psi with respect to t equals the Hamiltonian operator acting on psi. In this sense, the quantum world is as determined as the classical block universe. The wave function of the entire universe, if such a thing exists, evolves unitarily and deterministically forward in time. But quantum mechanics also has the Born rule, the rule that says the probability of finding a particle in a given state is the squared modulus of its amplitude, p equals mod psi squared. When a measurement is made, the deterministic evolution appears to give way to a probabilistic outcome. Different measurements yield different results with different probabilities. The pattern of probabilities is deterministic. The individual outcome is not. This tension between the unitary determinism of the Schrödinger equation and the probabilistic determinacy of individual measurement results is called the measurement problem. It has not been solved. Notice what this does to the block universe argument. If the future outcomes of individual quantum events are not determined by the past, if the Born rule is fundamental rather than reducible to some hidden deterministic story, then the future cannot be, strictly speaking, laid out in advance. There would still be a space-time manifold. There would still be a Lorentz transformation. There would still be a 6-day offset at Andromeda. But the events on the far side of any measurement would not yet be a fixed slice through the block, because the block itself would not be fully determined. Physicists have not agreed on what to do with this. Some, following Hugh Everett III's 1957 relative state formulation, say that every measurement outcome is realized in a branching universal wave function. This is the many worlds interpretation. It preserves unitary determinism at the price of an unobservable, ever-branching multiverse. On this view, the block is really a bushy branching structure that contains every possible outcome. Every walker's every step, every Andromedan event, every measurement in every laboratory. Every branch is fully real. Others reject this move. Carlo Rovelli, the Italian theoretical physicist who has done fundamental work on loop quantum gravity, proposed in 1996 an interpretation called relational quantum mechanics. On this view, quantum states are not absolute properties of systems. They are relational. They describe the state of one system relative to another. There is no view from nowhere from which the wave function of the universe can be surveyed. Every measurement is a relation between two physical systems, and the values of variables are only defined relative to that relation. For our purposes, Rovelli's move is important because he explicitly rejects both presentism and Putnam's eternalism. In a paper titled Neither Presentism Nor Eternalism, Rovelli argues that special relativity destroys the presentist view of an absolute universal now, but does not force us into Putnam's block universe conclusion either. Rovelli's charge, worth quoting in the exact spirit of his phrasing, is that Putnam misinterprets Einstein's simultaneity and mixes relativistic and non-relativistic concepts, making up a mess. In Rovelli's reading, Einstein did not discover that there are many equally real simultaneity surfaces. He discovered that simultaneity itself has no ontological meaning beyond convention. Destroying an absolute now does not, on Rovelli's argument, promote all events to equal reality. It leaves open a third position, in which reality is exhausted by relations between systems and by no other structure. This is important, and we will come back to it. Keep it as a seed for later. The argument that eternalism follows from relativity depends on there being no honest third position between eternalism and presentism. If there is a third position, the proof collapses back into an interpretive choice. There are other interpretations of quantum mechanics that are even more relevant here. The transactional interpretation, proposed by the American physicist John Cramer in 1986, treats a quantum event not as a one-way process running forward in time, but as a kind of handshake. An offer wave running forward in time, met by a confirmation wave running backward in time from the absorber. The transaction, as Cramer describes it, is atemporal. It does not happen at a single point in time. It happens along the whole space-time path connecting emitter and absorber. Wave function collapse, on this view, is not an event within time, but a feature of a transaction that spans time. Cramer has been explicit about the retrocausal flavor of this picture. In a 2020 interview, he described the situation as nature sending messages backwards in time, but not letting the observer in on the action. The interpretation is controversial. Tim Maudlin, a philosopher of physics we will meet again, raised an objection in 1996 known as the contingent absorber problem, generally considered a strong refutation of the original transactional picture. Ruth Kastner has developed possibilist transactional interpretation that responds to Maudlin's objection by locating the offer and confirmation waves in a pre-space-time realm of possibilities. Whether that response succeeds is still under argument. What matters for our story is this. The block universe, as presented in the Rietdijk-Putnam argument, is a purely classical block. It is a static, four-dimensional manifold in which every event is fixed. But the actual physics of quantum mechanics does not obviously fit inside such a block. It fits inside the block only under specific interpretations, each of which imports metaphysical commitments, extra worlds, or atemporal transactions, or relational-only realities that go beyond the plain classical picture. The block is not a neutral consequence of physics. It is a metaphysical layer added to physics under one interpretation among several. Foreshadowing. This will matter enormously when the examination begins, where the eternalist claim that the future is already fixed will be tested against exactly this crack. Return to the geometry and go further. Special relativity, the framework in which the Andromeda argument was born, describes flat space-time. It ignores gravity. General relativity, Einstein's 1915 upgrade, adds gravity by allowing space-time itself to be curved by matter and energy. And once you allow curvature, some of the strangest known solutions of the Einstein field equations become possible. In 1949, the Austrian logician Kurt Gödel, who had already changed mathematics with his incompleteness theorems, presented a specific, exact solution of Einstein's equations as a birthday gift for Einstein's 70th. It described a rotating universe filled with pressureless dust, with a negative cosmological constant. The mathematical fact Gödel proved was extraordinary. In this universe, there exist closed time-like curves, world lines that loop back on themselves. An observer in such a universe could, at least in principle, travel into their own past. Gödel's universe is not our universe. There is no evidence that the actual cosmos is rotating in the way his solution requires. That is not the point. The point is that general relativity, the deepest classical theory of space and time we have, does not, by itself, exclude time loops. The mathematics allows them. The Kerr metric, discovered by the New Zealand mathematician Roy Kerr in 1963, is a solution describing a rotating black hole. Its structure is more complex than the non-rotating Schwarzschild black hole. It has an outer event horizon and, inside that, an inner horizon. Between the two horizons, the roles of time and space swap. Outside the outer horizon, but still within a region called the ergosphere, no observer can remain stationary. The rotation of the black hole drags space-time along with it, a phenomenon called frame dragging, or the Lenser-Thirring effect. Inside the inner horizon of a Kerr black hole, in the mathematical solution, closed time-like curves reappear. There is a caveat here that any honest treatment should flag. A recent 2024 paper, which the research file marks for verification, argues that closed Timelike geodesics, the freely falling versions of these curves, do not exist in the physical Kerr geometry, and that some of the Kerr-Newman closed Timelike curves may be coordinate artifacts. The full picture is contested. What is not contested is that the mathematics of rotating solutions in general relativity contains, at minimum, curves whose interpretation is deeply strange. Enter Igor Novikov, the Russian astrophysicist who, together with Kip Thorne, Ulvi Yurtsever and colleagues, worked in 1990 on a striking question. If closed time-like curves are mathematically possible, what happens to physics on them? Their answer, published in Physical Review D42, was the self-consistency principle. In the exact wording of that 1990 paper, a local solution to the equations of physics can occur in the real universe only if it can be extended to be part of a global solution, one which is well defined throughout the non-singular regions of classical spacetime. In everyday language, on a closed time-like curve, only histories that are consistent with themselves can happen. Paradoxes, the grandfather kind, the kill-your-own-past-self kind, are excluded by the structure of the physics. The bullet is jammed. The trigger is snagged. Something always prevents the contradiction. The block universe reading of this is, in a sense, natural. If the whole spacetime, including the closed time-like curves, is a self-consistent four-dimensional structure, then the future of any point on such a curve is, by construction, exactly what leads back around to its own past. There is no room for the local choice to have gone differently. The consistency is baked in. Notice how the pieces are stacking. Special relativity tilts simultaneity planes. General relativity permits closed time-like curves in rotating solutions. Novikov and Thorne argue that on such curves, only self-consistent histories occur. Rietdijk and Putnam argue that the tilted planes prove eternalism. The overall picture, for a reader open to it, is of a physical universe whose past, present and future are all one static structure, in which apparent choices are the way the structure looks from inside. That is the eternalist case, honestly stated. It is worth pausing to notice what this does to Einstein's own comment about the stubbornly persistent illusion. Read straightforwardly, the letter to Besso's family looks like an endorsement of exactly this picture. If past, present and future are equally real, then the sense of one dying before the other is an artifact of subjective psychology, not a fact about the universe. That is what Einstein appears to be saying to console the family. Your loss is not ultimately a loss. We will return to this too. Einstein's other statement, the one recorded by Carnap, has a very different flavour. In one letter he says, the distinction between past, present and future is only an illusion. In another remark he says that the experience of the now is something science cannot grasp, and that this failure was to him a matter of painful but inevitable resignation. Both statements are from the same man. They point in opposite directions. Which one is closer to what Einstein really thought is a matter of scholarly debate. The scholarship also disagrees on how to read Rovelli's public statements. Rovelli has, in interviews and popular books, said things that sound eternalist. He has also, in technical papers, explicitly rejected eternalism. These are not contradictions if you attend to what is being said. A destruction of the absolute now is not the same thing as an assertion of a fully real future. It is precisely because these subtleties are easy to lose in popular treatments that we have spent so much time laying out the pieces. Let us pull one more strand into the light, the strand of experiment. The Rietdijk-Putnam argument is a mathematical inference from special relativity. It does not, in itself, require any new experiment. But general relativity has been tested at higher and higher precision for over a century, and one particular experiment is directly relevant to the frame-dragging piece of our picture. In April of 2004, NASA and Stanford launched a small spacecraft called Gravity Probe B. Its mission was to measure two subtle general relativistic effects on cryogenic gyroscopes in polar orbit around the Earth. The first was the geodetic effect, a precession caused by the curvature of space-time by Earth's mass. The second was the frame-dragging effect, a precession caused by the rotation of Earth dragging space-time along with it. The results were announced on the 4th of May 2011 and published in Physical Review Letters, Volume 106, page 221101. The measured geodetic drift was minus 6,601.8 milliarcseconds per year, plus or minus 18.3, against a general relativistic prediction of minus 6,606.1. The measured frame-dragging drift was minus 37.2 milliarcseconds per year, plus or minus 7.2, against a prediction of minus 39.2. The geodetic effect was confirmed to better than 1 part in 200. The frame-dragging effect was confirmed to about 19%, well within the mission's error budget. Frame-dragging, the piece of general relativity that turns space into something that a rotating mass can drag, is now a directly measured phenomenon of the real world. Consider that number for a moment. 19% error on a measurement of the rotation of empty space around a moving planet using cryogenic gyroscopes floating in a satellite. This is not philosophy. This is what physics can measure when it is careful. The block universe argument is anchored to the same equations that made this measurement possible. Now, the last piece of the deeper landscape. The block universe, taken at face value, sits at the intersection of several unresolved puzzles. One of the sharpest is what physicists call the problem of time in quantum gravity. In an attempt to combine general relativity with quantum mechanics, Bryce DeWitt, following work by John Wheeler, wrote down in 1967 what is now called the Wheeler-DeWitt equation. In its cleanest form, it is a striking piece of mathematics. H hat acting on psi equals 0. Speakable. The Hamiltonian operator acting on the wave function gives 0. The equation has no time parameter. It describes a state, not an evolution. Taken literally, it seems to say that the universe as a whole does not change. It just is, all at once. The British theoretical physicist Julian Barbour has taken this seriously in a way most of his colleagues have not. In his 1999 book, The End of Time, and in a body of papers and public writing, Barbour argues that time itself does not fundamentally exist. Reality, on his view, is a static configuration space he calls Platonia, a timeless mathematical landscape in which each point is a complete, instantaneous now. The apparent flow of time is emergent. It comes from the way certain kinds of configurations, what he calls time capsules, like the tracks in a cloud chamber, contain within them the internal evidence of an ordered past. On Barbour's own website, he describes Platonia as timeless, created by perfect mathematical rules, with each point in the country a now. He also concedes in the same writing that the Wheeler-DeWitt approach remains controversial. Barbour's timeless picture is not the standard block universe. It is more radical. The standard block still has 4 dimensions and a temporal direction. Barbour's Platonia has no dimensions in the ordinary sense at all. It is a natural extension of the eternalist impulse. If the future is already there, why should there even be a flow in the first place? This is where the deeper current is running. The Andromeda paradox sends up a first flag. The Rietdijk-Putnam argument turns that flag into a formal claim about ontology. The Petkov argument roots the claim in the structure of length contraction and time dilation themselves. The Wheeler-DeWitt equation seems to remove time from fundamental physics altogether. Barbour's Platonia takes the removal to its logical conclusion. And the block universe, in the strong form, invites the conclusion that there is nothing left of the now but subjective psychology. Notice what the current is quietly doing. Every step tightens the noose on the ordinary experience of time. Every step widens the gap between what physics says exists and what human beings feel when they live through a day. The direction of travel, taken far enough, is toward a picture in which the whole of history is a static mathematical object, and every apparent decision is a feature of the structure, seen from the inside. We will return to this direction and ask, hard, whether the physics actually forces it, or whether the physics has been used as a cover for a philosophical preference. Not yet. This part is still about the map, not the verdict. Halfway through this exploration, an aspect worth naming quietly is the shape of the now itself. A topic another exploration on this channel follows deeper. If that question stays with you, you will find where. Now the honest description of what is actually observed, before we start the examination. At the position of Andromeda, we can observe the light of stars, the emission of hot gas, the absorption features of interstellar dust. We can measure Andromeda's approach velocity along our line of sight, about 110 kilometers per second, or about 68.4 miles per second, blue-shifted toward us. We can measure the sideways motion of Andromeda across the sky. In 2012, Sohn, Anderson and van der Marel used precise Hubble measurements to find Andromeda's tangential velocity to be less than 1/10 of a milli-arcsecond per year, essentially zero on the scale of the collision timescale. Their conclusion was that Andromeda and the Milky Way are on a nearly head-on trajectory, with a merger predicted in something like 4 to 6 billion years. That result reached the popular press and lodged itself in the culture. A 2025 study by Sawala and colleagues using combined Hubble and Gaia data revised the odds substantially. Their analysis found roughly a 50-50 chance of a Milky Way-Andromeda collision within the next 10 billion years, with only about a 2% chance of a head-on collision in 4 to 5 billion years. Andromeda's future collision with our galaxy, if it happens at all, is now much less certain than the popular narrative suggests. Two galaxies drifting toward each other with a 50% chance of a merger in a stretch of time longer than the current age of the universe is a very different picture from a certain doom in 4 billion years. For our purposes, the collision is a side story. The main thread is that we can measure Andromeda in exquisite detail. Its light, its motion, its composition, the paths of the individual stars. Its Hubble telescope survey has resolved, and yet, when we ask what is happening at Andromeda right now, in the sense of the Rietdijk-Putnam argument, we run into the tilt of a simultaneity plane. A slow walk changes the answer by 6 days. The change is real in the mathematics. Whether it is real in any deeper sense is what the examination is about. Let me now name the assumption. The Rietdijk-Putnam argument, in the form we have seen it, moves from 3 claims to a conclusion. Claim 1. For any observer at any event, there is a well-defined plane of simultaneity, a global 3-dimensional slice through space-time containing every event that observer calls now. Claim 2. Every event on that slice is as real as the observer at the origin of the slice. Claim 3. The reality of an event does not depend on which frame is used to label it. From these 3 claims, the eternalist conclusion follows. Different observers passing through the same point in space-time in relative motion have different slices. If the events on each slice are real, and if reality is not frame-dependent, then all events on all slices are real. Iterating, everything in the block is real. The physics gives us the tilts of the slices. The physics gives us the 6-day offset at Andromeda. The physics gives us the Lorentz transformation. But look carefully at Claim 1 and Claim 2. These are not physics. They are philosophy. Claim 1 asserts that a global plane of simultaneity is a real geometric object. Claim 2 asserts that the events on it share the reality of the observer at the origin. Neither claim is derived from the equations. Both are assumed. The physics is compatible with them. The physics does not force them. This is the wedge that the sharpest critics of the block universe have driven into the argument, and it is where the examination begins. Now the examination. The evidence has been fairly presented. Now we test it. The prosecution of the strong block universe claim does not require any exotic physics. It requires that we take the mathematical structure seriously and refuse to grant assumptions the mathematics does not force. The single most technically careful critic of the Rietdijk-Putnam argument is the American philosopher of physics Howard Stein, who published a pair of papers in 1968 and 1991 that many working philosophers consider decisive. His argument runs like this. In special relativity, the notion of simultaneity is frame relative. Two events that are simultaneous in one frame are not simultaneous in another frame, in relative motion. So far, this is uncontroversial physics. The Rietdijk-Putnam argument, then, wants to elevate the frame-relative notion of simultaneity to something ontologically weighty, to say that each observer's plane of simultaneity is a slice of what is real for that observer. Stein points out that the relation simultaneous in some frame is not transitive. Event E can be simultaneous with event F in one frame, and F can be simultaneous with event G in another frame, without E being simultaneous with G in any frame. If you use this relation as your definition of is real relative to, you get a definition that lets everything be real relative to everything else, which is either a proof of eternalism or a proof that the relation is the wrong one to use. Stein argues that the right notion of definite as of in relativity is not a global simultaneity plane at all. It is the past light cone of a point. Everything that could have causally influenced the observer at that point is definite as of the observer's here now. Nothing outside the past light cone is. On this reading, the present in relativity is a local point-like structure, not a global slicing of space-time. Andromeda events are not in any observer's present. They are outside the past light cone of every walker on the sidewalk. The disagreement between the two pedestrians is a disagreement about a coordinate label, not a disagreement about reality. Notice what Stein has done. He has refused to grant Claim 1. He has denied that a global plane of simultaneity is a real geometric object. He has replaced it with the past light cone, a structure that every observer at the same point in space-time shares, and about which no two observers in relative motion can disagree. On Stein's reading, the Rietdijk-Putnam argument's central move from tilted planes to ontological entailments is a category error. It treats a coordinate device as if it were an object. This is not a minor rebuttal. This is a technical refutation from within the same mathematical framework the eternalists are using. Clifton and Hogarth, in a 1995 paper, described Stein's response as having settled the issue. Vesselin Petkov contests this, arguing that Stein's reduction of the present to a single zero-dimensional point is not tenable. The literature is not unanimous, but the technical case against the Rietdijk-Putnam inference is strong enough that it cannot be waved away. There is another line of attack, older and more elementary. It goes back to Reichenbach's insistence, later sharpened by Bernard Weingard and others, that distant simultaneity in relativity is conventional. Reichenbach observed that the very definition of two spatially separated events as simultaneous depends on a choice of synchronization convention. The standard choice, sometimes called the Einstein convention, uses the assumption that light travels at the same speed in both directions along any path. This assumption is not directly testable. Any test requires already synchronized clocks at both ends. Reichenbach parameterized the freedom with a factor he called epsilon, and showed that a whole family of consistent synchronization schemes are compatible with the observed physics. The Einstein convention picks one member of that family. Others are, in principle, equally valid. If distant simultaneity is a convention, then the plane of simultaneity is a coordinate choice, not a fact of the world. The tilt between two observers' planes is a tilt between two conventional labelings, not a tilt between two real slices of a real block. The Rietdijk-Putnam argument that different observers have different real presence, and that all these real presents must jointly exhaust all of reality, quietly slides between two meanings of present. It uses the mathematical coordinate-dependent meaning to derive its conclusion, and then it treats the conclusion as if it were about a coordinate-independent reality. N. David Mermin, one of the most careful physicists to write on the foundations of relativity, put the point plainly in his 2021 book, It's About Time. The single most important lesson to be learned from relativity, he wrote, is that no inherent meaning can be assigned to the simultaneity of distant events. If Mermin is right, the block universe conclusion is not a discovery. It is a mistake. A mistake that pretends a chosen coordinate labeling is a discovered fact. Return now to the first anti-theistic claim that the block universe framing quietly smuggles in. The strong Rietdijk reading, the reading Rietdijk himself defended in the title of his 1966 paper, says that the future is fixed and therefore choice is illusion. The materialist who accepts this reading concludes that human agency, deliberation, moral responsibility, and the felt sense of an open future are all artifacts of subjective psychology, projected onto a static structure that does not contain them. Look at what has to be granted for this conclusion to land. First, the block universe interpretation of special relativity has to be correct. The strong Petkov version, not the deflated Rovelli version. Second, general relativity's classical picture of a fully determined manifold has to survive quantization. Third, the measurement problem in quantum mechanics has to be resolved in a way that preserves determinism, either through many worlds, which multiplies branches indefinitely, or through some other mechanism that recovers unitary evolution without probabilistic outcomes. Fourth, the identification of physical determinism with no free will has to be granted rather than argued. Every one of these steps is contested. Every one of them assumes something the physics does not force. And the fourth step is not even a physics step. It is a philosophical claim about the relationship between determinism and freedom. A claim that has been argued about for more than 2,000 years and shows no sign of being settled by the equations of any one theory. Consider what the American philosopher Daniel Dennett has said about this. Dennett is not a theist. He is a naturalist in the strongest sense. But he spent his career arguing that the standard conflation of determinism with fatalism is a mistake. Determinism, on Dennett's reading, is the thesis that the laws of physics determine the evolution of physical states given the initial conditions. Inevitability, or fatalism, is the very different thesis that no matter what an agent does, the outcome will be the same. Determinism does not entail inevitability. In a determined universe, what an agent does still matters. It is part of the causal chain that determines what happens next. DeWitt introduced a technical term for this: evitability. In a determined universe, most outcomes are evitable. Human agents, with their capacity for reasoned anticipation and control, are effective at evading many outcomes that would otherwise befall them. That is what evitability means. And that is what freedom, in the sense worth wanting, is. Whether DeWitt is right, whether compatibilism actually preserves the kind of responsibility a moral realist needs, is a question that has been argued at length by philosophers like Robert Caine and hard incompatibilists on the other side. What matters here is that the transition from "the physics is deterministic" to "you have no free will" is not a physics claim. It is a philosophical thesis, and one that trained philosophers do not agree on. Now do the reductio. Suppose, for the sake of argument, that the strong Rietdijk reading is right, and choice is an illusion. Then the sentence, "we should accept the Rietdijk argument because the evidence supports it," is itself an illusion. There is no should, no we, no evaluation of evidence in any normatively binding sense. There is only whatever the block already contains, laid out from the beginning. Rietdijk's paper, if his own conclusion holds, is not an argument. It is a shape in the block. It has no more claim to be believed than any other shape in the block. The argument, if valid, self-destructs. Every claim to have followed the reasoning is a feature of the static structure, a feature that could not have been otherwise, and about which the word correct has no anchor. This is the shape of the trap. The strong eternalist reading, applied consistently to itself, undermines the very concept of following the argument. If the reader can freely follow the argument, the conclusion is wrong. If the reader cannot, there is no one to accept the conclusion. Either way, the position collapses. There is a milder eternalism that avoids this trap. It says the future is real, but the felt sense of an open future is a legitimate psychological reality, and reasoning is what real agents inside the block do to determine which branch of the block they realize. This is close to DeWitt's compatibilism, and it does not have the paradoxical self-cancellation of the strong reading. This milder eternalism is not what Rietdijk argued for. It is not what Putnam argued for. And it does no work as an anti-theistic claim, because it makes room for agency, responsibility, and evaluation of reasons, the very ingredients a theistic account of human beings requires. There is a second claim in the block universe cluster that is worth naming and testing. It is the claim that experienced passage of time is a mere illusion, a subjective side effect of a static structure. This is the claim that seems to be endorsed by Einstein's letter to Besso's family. It is the claim that has passed into popular culture as physics has shown that time doesn't exist. The philosopher Tim Maudlin has argued, at book length, that this claim is false. In The Metaphysics Within Physics, and in his subsequent remarks on Passing of Time, Maudlin defends what he calls the reality of temporal passage. His argument is not a hand-wave. It is a careful metaphysical position worked out with attention to the structure of space-time. The passage of time, he writes, is a fundamental, irreducible fact about the spatio-temporal structure of the world. It is an intrinsic asymmetry in the structure of space-time itself, an asymmetry that has no spatial counterpart and is metaphysically independent of the material contents of space-time, independent, for example, of the entropy gradient of the universe. Notice what Maudlin is doing. He is not denying the block universe. He is denying that the block universe is a static block. He is arguing that space-time has a fundamental temporal direction, that it is asymmetric under time reversal in a way that is not reducible to any other structure. On his view, both eternalism and the reality of passage are correct. The past is real, the future is real, and time genuinely passes. Not every philosopher agrees with Maudlin's position, but his argument shows something important. The claim that the block universe implies no passage of time is not a straightforward consequence of the physics. It is a specific metaphysical interpretation, and one that the leading defender of the reality of passage rejects. In a debate between Maudlin and the popular interpretation of Einstein's letter, Maudlin has said flatly in an interview for IAI TV that nothing in Einstein's theory of relativity suggests that the distinction between past, present and future is an illusion. Take that in. The claim that Einstein said time is an illusion comes from a single personal letter written to console a friend's family. The claim that relativity implies time is an illusion is not the same claim. And the second claim, the physics claim, is contested by leading philosophers of physics on both sides of the eternalism debate. We can go further. Consider what the Italian physicist Carlo Rovelli has written about Einstein's stubborn illusion sentence. Rovelli argues that Putnam misinterprets Einstein's simultaneity and mixes relativistic and non-relativistic concepts, making up a mess. In particular, Rovelli writes, Einstein's simultaneity is not a discovery of a fact of the matter about multiple simultaneity surfaces. It is the discovery that simultaneity has no ontological meaning beyond convention. This destroys presentism, Rovelli says, but does not force us into Putnam's eternalism. This matters enormously. Rovelli, who has written a best-selling popular book called The Order of Time, is often quoted in popular treatments as if he endorsed the strong eternalist view. He does not. He has explicitly rejected it in the peer-reviewed literature. His view is that both presentism and eternalism are wrong, and that the correct picture is one in which reality is exhausted by relations between systems. That is a very different position from Rietdijk's determinism. Now the third claim, that there is no need for a creator because the block is eternal and self-standing. Julian Barbour's Platonia and various strong eternalist readings are sometimes taken to imply that if the entire space-time manifold, or the whole of Platonia, exists as a static structure, there is nothing left to explain. The universe is. There is no need for a beginning, and therefore no need for a cause, and therefore no need for anything beyond the manifold itself. This is the claim that most invites the eternalist framing to be pressed into anti-theistic service. It is also the claim that, on inspection, does the least work. Consider what has been assumed. Even if the block is eternal, even if there is no first moment and no boundary to space-time and no beginning of any kind, the specific block still needs an explanation. Why this manifold with these fine-tuned initial conditions? Why a manifold with a low entropy early state so unusual that Roger Penrose himself has estimated its odds against random selection at 1 part in 10 raised to the 10 raised to the 123 power, a number so vast it dwarfs a Googleplex. Why a manifold in which physical constants, the fine structure constant, the gravitational coupling, the cosmological constant, take the specific values they do, values that would seem to be freely dialable across a range of possibilities? Barbour concedes that his own Platonia is speculative. He writes on his own website that the Wheeler-DeWitt basis of the timeless picture remains controversial. Even if Platonia is right, and reality is a static, timeless mathematical landscape, the question of why this particular landscape exists, with the structure it has, with the possibilities it contains, with the specific time capsules its configurations encode, is not answered by the landscape's existence. Think about a locksmith examining a lock. He can describe every tumbler, every spring, every mechanism. He can prove that the mechanism is internally consistent, that it does what it does with mathematical precision. What he cannot do from within the mechanism is explain who designed it or why. The description of the mechanism is complete, and it is also silent on the origin. That silence is the space in which the question of the manifold's cause lives. Timelessness does not fill it. Eternalness does not fill it. An eternal object is still contingent, could have been otherwise, unless it is something whose existence explains itself. And no manifold of possibilities explains its own existence. Consider the way ordinary human life works. A person builds a home. The home has a foundation, walls, a roof. All the parts fit together. The whole thing stands. Someone visits and asks, "Why is this home here?" The answer is not because the parts fit together. The answer is because a person decided to build it, and did. The internal consistency of the home does not explain why the home exists rather than a vacant lot. The internal consistency of a static mathematical block does not explain why the block exists rather than nothing. The analogy fits until the crucial point, until you notice that a house has a maker whose existence lies outside the house, and try to say the same thing about the block. This is where the everyday analogy breaks down, and the breakdown is the point. A house's builder is another created thing, in another universe of contingent objects. But the block universe, if it is all there is, has no builder within the same category. If there is no builder outside the category, the block is left hanging, contingent, unexplained. The breakdown of the analogy exposes exactly the gap the block universe framing cannot fill. Something with the power to make an entire manifold real must exist outside the manifold, must be uncontingent, must be its own reason. Every human analogy for construction points that direction. The block does not remove the question. It sharpens it. Notice how the naturalistic responses stack up. To explain the low entropy initial state, some cosmologists invoke a multiverse, infinitely many bubble universes with random initial conditions, one of which happens to be ours. But the multiverse has no direct evidence. Sean Carroll and Jennifer Chen, in a 2004 paper, proposed a specific mechanism by which the arrow of time could emerge from an underlying time-symmetric multiverse of baby universes. Carroll himself has been candid about the status of this proposal. On his website, he writes that the arrow of time can be explained without assuming a special initial state, and then acknowledges that the proposal is still in the realm of speculation. Roger Penrose has proposed his own alternative, called conformal cyclic cosmology, in which the universe's low entropy start is explained by an infinite sequence of prior eons whose end conditions become the beginning of the next. It, too, is highly speculative and lacks decisive observational support. Look at what has happened. The block, taken as final, does not explain the fine-tuning. To avoid a designer, the naturalist multiplies universes, invoking multiverses, baby universes, cyclic eons, all of which are, by the acknowledgement of their own advocates, speculative and unobserved. What is the multiverse at bottom, if not naturalism of the gaps? An unfalsifiable entity invented specifically to avoid the conclusion the evidence suggests. There is a rhetorical move that materialists frequently use here, and it should be named. When theists argue that the fine-tuning of the universe points to design, materialists reply that this is a God of the gaps argument, an appeal to a designer to fill in what science has not yet explained. Look at the parallel move. When materialists argue that the fine-tuning does not point to design, they appeal to a multiverse. The multiverse has no evidence. No other universe has been observed, measured, or detected. The theory is unfalsifiable. No possible observation could disprove it. What is this, if not a naturalism of the gaps? The gap is real. The fine-tuning is genuinely improbable on the assumption of chance. The response is to fill the gap with an unobserved entity whose existence would neutralize the improbability. This is exactly the structure the theist is accused of using. It is invoked, in this case, by the very thinkers who accuse the theist. There is a related move worth exposing. Ask a materialist why there is something rather than nothing. Watch the response. They will redefine nothing. The nothing of physics, they will say, is really a quantum vacuum, or a set of fluctuating fields, or a superposition of possibilities. A quantum vacuum is something. Fluctuating fields are something. A superposition of possibilities is something. Absolute nothingness, no matter, no energy, no fields, no laws, no possibilities, cannot produce anything. If there was ever such a nothingness, there would still be nothing forever. That we exist proves that something has always existed. The question is what? And that question does not have a naturalistic answer. Whatever has always existed cannot itself be a piece of the block that came from nothing. The multiverse does not answer this. The block universe does not answer this. Platonia does not answer this. Every one of them shifts the question. Every one of them takes an unexplained brute fact, the existence of the manifold, the collection of universes, the structure of possibilities, and rests on it. The theist is at least honest about the brute fact. What has always existed is not an unconscious block, but a conscious cause with power, knowledge, and will. That answer is not evasion. It is the direct confrontation of what the evidence requires. Consider now the argument from consciousness, which the Andromeda paradox pushes into unusually sharp relief. If the block universe is right, if every event, including every conscious moment, is a fixed feature of a static structure, then the felt now is either a delusion or it is real. If it is a delusion, the consciousness that reports it must itself be part of the block, meaning the block contains its own systematic self-deception. That is not an explanation. That is an assertion of a mystery. If the now is real, if there is a genuine experienced present, of the kind Einstein admitted physics could not capture, then the block, as physics describes it, is incomplete. Something is missing from the description. And what is missing is precisely the ingredient physics has no equations for: the first-person subject who lives inside the structure and experiences it as unfolding. Consciousness cannot be explained by the block. Neurons in a determined structure do not, of themselves, produce subjective experience. The hard problem of consciousness, as it is now called, is the problem of explaining how any arrangement of unconscious matter, determined or not, could produce the first-person felt quality of experience. Materialism has no answer. It has been trying for a century. The gap is not shrinking. The theist has an answer. Consciousness is not produced by the block. Consciousness is a real feature of created beings, a gift of the intelligent cause that stands behind the block. The block is a stage. The actors are not made of the stage. They are made by the one who set the stage in place. This is not a proof. It is an interpretation. It is an interpretation that does not have to explain how the felt now arose from unconscious matter, because it does not insist that unconscious matter is all there is. Consider a thought experiment. Imagine you found a book in the desert. The pages are filled with coherent language, complex grammar, meaningful sentences. Would you conclude the wind arranged the sand into these patterns? Or would you infer an author? The book is a finite object. The universe is much more than a finite object. It contains not only structured information, the codes of physics, the mathematical relations that hold across galactic scales, but also readers of that information. The universe contains beings who can ask what its structure means. The materialist story asks us to accept that the book, the wind, and the reader all arose from the same unmindful process. The theist asks, does that story explain, or does it merely assert? There is a fourth claim in the anti-theistic cluster that has to be examined. It is the claim that in a determined block, moral responsibility is impossible, and therefore that objective morality is a fiction. If choice is illusion, the argument runs, then holding people responsible for their actions is like blaming a rock for falling. Moral outrage becomes as meaningless as blaming a river for flowing downhill. This argument, examined carefully, does the same work against itself that the Rietdijk determinism does. If moral responsibility is impossible, then holding materialists responsible for making bad arguments is impossible. And yet, the very act of arguing that morality is subjective assumes that the interlocutors ought to accept good reasoning over bad, a normative claim that has no anchor in a determined block. Every human society, without exception, distinguishes good from evil. The universality of the moral sense, across cultures and centuries, is a datum that requires explanation. The materialist cannot appeal to evolved instinct without importing a normative sense that instincts were correctly tuned for something. But correctly tuned relative to what standard? The materialist can appeal to game theory without explaining why the outcomes of that game should matter. Moral objectivity is not a theistic invention. It is an observation about how every human being, including atheists, actually thinks and speaks. And it survives only if it is grounded in something beyond the block. Notice how these threads knot together. The Andromeda paradox, taken as a proof of eternalism, is used to argue against free will. That argument, applied to itself, self-destructs. Even if eternalism is granted, it cannot ground the elimination of choice without eliminating the reasoning by which it is defended. And the eternalist framing, even if it survives its internal problems, does not remove the need to explain why this particular block, with these particular initial conditions, exists rather than nothing. Fine-tuning still requires explanation. Consciousness still requires explanation. Objective morality still requires explanation. The block, as a static object, is fully compatible with, and on inspection, fully requires, a cause that stands outside it. The intelligent cause that classical monotheism has always described. Return to Einstein's other admission, the one Carnap recorded. Einstein said that the problem of the now worried him seriously. He said that the experience of the now means something special for man, essentially different from past and future. But that this important difference does not and cannot occur within physics. He said that this experience cannot be grasped by science, and that this was to him a matter of painful but inevitable resignation. Read that carefully. This is not the eternalist manifesto that the letter to Besso's family is often taken to be. This is Einstein, the same Einstein, admitting in a philosophical conversation that physics cannot account for the felt now, and that this failure was a source of ongoing distress to him. He was not celebrating the elimination of the present. He was mourning it as a limit of the physical description. The physics did not persuade him that the felt now was unreal. It persuaded him that physics could not reach it. Two different things. This is where the honest evidence points. Special relativity produces a mathematical offset, 6 days at Andromeda, between the coordinate labels of two walkers on a sidewalk. That offset is real as mathematics. It is not real as ontology, because the identification of a coordinate slice with a slice of what exists requires an assumption the physics does not force. The offset does not prove that the future is fixed. It does not prove that consciousness is illusion. It does not prove that morality is subjective. It does not prove that the block is self-standing. It reveals a limitation in the ordinary notion of a global present, and it opens a philosophical space in which those larger questions can be asked. It does not close any of them. Consider what the evidence actually requires. It requires that whatever exists, whatever the manifold, or the collection of possibilities, or the underlying reality, has the properties needed to sustain the existence of conscious beings who can measure it, describe it, and follow arguments about it. It requires an initial state of extraordinary specificity, whose probability against random chance is a number effectively indistinguishable from zero. It requires a set of physical constants that could easily have been otherwise. It requires the emergence of first-person experience from a structure whose fundamental equations contain no term for the first person. Every one of these requirements points toward something, not toward randomness, not toward blind, unconscious matter, toward an intelligent cause with the power to configure a manifold, the knowledge to specify its constants, and the will to make the specification actual. The materialist alternatives, multiverses, cyclic universes, block universes as brute facts, do not answer these requirements. They restate them. They shift the location of the mystery without dissolving it. The theist does not shift the mystery. The theist names it. What has always existed is an intelligent cause, uncaused, outside the block, on which the block itself depends. This is where the evidence lands when it is followed honestly. It is not agnosticism. It is not, we may never know. It is the position that the whole shape of the paradox, the walker, the sidewalk, the Andromedan fleet, the tilt of a plane, the 6 days, the tests of relativity by gravity probe B, the equations that make satellites work, is compatible with, and rationally best explained by, an intelligent cause that stands behind the manifold, made it what it is, and holds it in existence. Let me bring this exploration to a close. We began with a slow walk and a distant galaxy. We traced the mathematics of the Lorentz transformation to a 6-day offset in the Andromeda now. We followed Rietdijk and Putnam from that offset to a formal argument for eternalism, and Penrose to the dramatized version now known as the Andromeda paradox. We placed the block universe alongside the growing block, the presentist view, and the many interpretations of quantum mechanics, many worlds, relational quantum mechanics, the transactional interpretation that complicate any simple picture of a fixed future. We saw the closed time-like curves in Gödel's rotating universe and Kerr's rotating black holes, and Novikov's self-consistency principle that keeps their histories from tearing themselves apart. We noted the timeless Platonia of Julian Barbour, resting on the Wheeler-DeWitt equation, and the arrow of time proposals of Sean Carroll and David Albert. Then we examined. We saw that the Rietdijk-Putnam inference depends on an assumption the physics does not force. That a plane of simultaneity is a real geometric object whose events share the reality of the observer at its origin. Howard Stein's rebuttal reduced the present to a local, point-like structure. Reichenbach and Weingard reminded us that distant simultaneity is conventional. N. David Mermin summarized the honest lesson of relativity. No inherent meaning can be assigned to the simultaneity of distant events. Rovelli explicitly rejected Putnam's eternalism even while destroying presentism. Maudlin defended the reality of temporal passage from inside the block. DeWitt showed that determinism does not entail the elimination of choice. We tested the anti-theistic conclusions. The strong Rietdijk reading, applied to itself, cancels the possibility of following its own argument. The elimination of consciousness leaves the felt now as an unexplained mystery inside the block, not as a resolution. The claim that the block needs no creator ignores the contingency of the specific manifold, the fine-tuning of the initial state whose odds are 1 part in 10 to the 10 to the 123, and the specific values of physical constants that could easily have been otherwise. The dismissal of moral responsibility cannot be argued for without importing normative claims the naturalist has no ground to make. The physics is real. The equations work. The gravity probe B measurement of frame dragging at minus 37.2 milliarc seconds per year is a genuine confirmation of a genuine effect. The Lorentz transformation gives us the 6 days at Andromeda's distance, whether we like it or not. What the physics does not do is force us into the anti-theistic conclusions that popular treatments sometimes wrap around it. Those conclusions require philosophical assumptions that the physics does not supply, and that, on inspection, fail to survive scrutiny. What does it mean that a slow walk on a sidewalk quietly re-slices the label present across a distance nothing can cross? It means the ordinary Newtonian idea of a shared universal now is not a fundamental feature of reality. It means that the labels observers assign to distant events are not privileged over one another. It does not mean that the future exists in a way that eliminates choice, or that consciousness is an illusion, or that there is no cause behind the manifold that carries the labels. Those are additions. Additions to the physics. Additions the physics does not require. If you found value in this exploration, consider subscribing. It helps these deep dives reach more curious minds. There is a related question this exploration has only opened. The question of whether the future is real in the same way the past is, or whether the block grows as events become present, leaving the future genuinely open. We touched that door here, but I have followed it much further elsewhere. If that question stayed with you, you will find where on the end screen now. Two strangers still walking. A galaxy still shining, its light 2.5 million years old on the way. A plane of simultaneity, tilted a hair's breadth in one frame and another. And behind all of it, holding it steady, the one who set the manifold in place. Outside every now, outside every slice, outside every version of the block, whose existence does not depend on the physics, and on whom the physics depends. Sleep well tonight, resting in a space-time whose every label, however tilted, however offset, however contested, still points beyond itself to the cause that made it labelable at all. Good night.